And we'll be starting with Robert and Cleverdist. So here you go. Here's your mic.
I have water.
Okay.
You can hear me, right? They wire me.
All right.
Okay, so I think I have a very tight schedule, and I can see that the clock started clicking already. So
15 minutes.
15 minutes, 50 slides. They said that it was impossible, so, and I answer, watch me. So let's get into it. Industrial operator. Imagine an army of operators embedded in every single piece of your infrastructure, your power plants, your water plants, your trolleybus, whatever your system is. Operators that they don't need to sleep. They don't take sick leave, they never take holidays, and they are hyper-focused on their mission. This vision is something that we are making a reality today with industrial operator. But before I speak about that, not everyone knows Cleverdist in the room, so I will give a very quick introduction. Cleverdist, 10 years old. In fact, I realized that 10 years ago, I made my first presentation in a user day, so I'm super happy to be here today. We are based in Geneva, in Switzerland. One of the reasons why we are there is because many of the founding team, we spent many years at CERN developing some of the largest control systems in the world. By the way, 70 million IOs, aggregated WinCC OA system, so very large systems. And yeah, I showed actually this slide 10 years ago, where I was showing what is happening in the technologically, what is people capable to do in the lab versus the adoption in industry. And well, today, as you may have noticed, there's no difference. But now we have a real hope that with industrial operator, we will be able to bend this curve and bring all those AI lab improvements into industrial systems. I'm just going to browse very quickly through a few of our references. Of course, we still work with CERN, we work with ITER and all these research labs. We also have a collaboration, R&D collaboration for generative AI for industrial control systems with CERN. We are, since a few years already, working with Geneva and Zurich Airport, providing support for the maintenance of the critical infrastructure. We are creating control centers for large power plants. Actually, this is a multi-power plant control system. I think it's 11 power plants, where, by the way, we have already piloted our industrial operator, as I will show in a second. Also, like I think Walker mentioned before, WinCC OA is not just a SCADA plus, but you can do much more. We build a complete operation systems in the petrochemical sector, connecting all the SCADA all the way to the ERP and managing all of the operations, traffic, whatever you might imagine in these systems. We also work now with Bruckner friends that they are here in the room. We're having a lot of fun working with these guys that they've been working with WinCC OA since the 2X version, so VBSS quite old. I will go very quickly through these next slides. I will be here outside in a fair, so anyone interested could have additional information. For many years, we developed our own framework to develop control systems. In fact, like Walker mentioned before, to provide those semantics into your system. We have a viewer that can provide semantics inside WinCC OA as well. And I'm going to fast forward to 2023. There's a big jump. So ChatGPT arrived end of 2022. By the beginning of 2023, with our DNA, we started to look heavily into that. We've been the last 2 years running and racing. You might have seen some of our videos online, where we demonstrated how we could already at the beginning of 2023 engineer a Mars colony. I'm a space fan. Yeah, when even the models were not capable of managing tools, we were already able to integrate that in our own IDE and creating WinCC OA control system to manage a Mars colony, for example, with the different devices and so on. Of course, since then, we've moved on. Walker mentioned many times MCP. We are currently using Cursor AI, which is a fork of Visual Studio, you might know, and we embedded all our engineering knowledge and experience with WinCC OA into our own MCP servers that they are connecting to WinCC OA, so our agents are now developing much faster than before. And not only they are developing, they are self-checking. They are connecting to WinCC OA and verifying that what they are developing is correct, and they are rectifying, and you can have your coffee while the agent is calling for you, basically. But engineering will be solved. It's a matter of 1.5 years, 2 years. I agree with Walker. If you're not using AI in 1.5, 2 years, you're going to be outpaced by your competitors, by your neighbors. We think that conceptually we have solved engineering and everything will improve. Our tools will improve, the AI models from the labs will improve, and this will be a multiplier effect. So we are now focused on the operations, where we believe that is the frontier. We develop once, but we use these systems every day. Already in 2024, we started piloting some of the systems with some of our partners. We created, by the second quarter of 2024, our first version of the industrial operator that I will be showing a short demo here and in the fair later on. Why is industrial operator very important? I think this should be obvious. This is about boosting operation productivity, so your operators can do more with the same effort. And of course, increasing the return on your assets. You have a more stable system, you have a more reliable system, you have a higher return on your assets. Let's go into the demo. So this is an AI-generated image, so it's a bit messy, to be honest. But you just have to keep in mind that in the next demonstration, the system is just trying to ensure that that pressure is around 5 bars, so we can start the heat recovery plant and the turbine and so on, and it knows that there are 3 pumps. So this is a version of the industrial operator that we put in production last year. We tested in real power plants. But I'm going to show a small example. You have to imagine that this is actually happening in the plant in parallel in many other processes. So we are just going to look at one single process, which is this generator seal oil system verification. So the first thing that happens is that the system can wake up and look at parts in a sequence, in this case starting the plant, where there is something going on that is not okay, so it's in red. So the system wakes up, and we provide, through NCP servers, through our own APIs, we provide a set of toolkit. You can imagine like a toolbox that we provide to the models, where they can actually start inspecting, making analytics, drawing for the user, and in an autonomous way, basically, troubleshooting what is going on in this step. So I don't need to chat with the thing anymore. It's autonomous. Of course I can. There is a chat window, as you can see. But the system is proactively already exploring what's going on. So in this case, we can see that they started using the tools, like sending messages, and also managing itself memory. It is managing events that happened in the past. Is writing in its memory and is retrieving the memory. So it's remembering that last time we have a problem like this, there were 3 pumps that the operator mentioned that were related to this specific process. So moving on, the system is starting to inspect those devices, so it will realize that possibly the pumps are not running and is deciding to show us a trend. I'm showing it very fast, but if you're interested, you will see this is real and we can test it and we can simulate any scenario that we want in the fair. So it can show widgets, like it can show a trend based on the historical values of the system, but it can also add a calculated curve in real time. So it could calculate the rate of change, it could calculate an average of signals, and it will draw it together in your WinCC OA with the historical signals. And that happens in real time, basically about a second. So showing widgets is another of the capability. And well, here we can see that the system is continuing reviewing exactly what is going on. Maybe we can have a quick look. And we can see that here is recommending to start one of those pumps because it identified that the pressure is very low, the 3 pumps are stopped, and it's recommending to start this pump. In this case, the system is very fine with the operator. This is a technical operation decision. It's not a technical. Of course, the system could be sending commands in an autonomous way. In this case, it's just verifying its idea with the operator. And then the operator still needs to do a confirmation. And of course, clicks OK. We are simulating on the background. This was not running in production. It's running in a simulation system. And the system will immediately start checking the history of the pump, of the pressure. It realizes, of course, the pressure didn't increase yet. I just started the pump, so the pressure needs to build up. And what it does in an autonomous way, there is nothing in the system saying you should do now this. It's just deciding to check in a couple of minutes. It understands that the pressure needs to build up. So it sets its own reminder if you want. So it sets the alarm. It says, OK, I will wake up in 2 minutes. and I will check again what is going on. By the way, it's also using an analytics module, which is very troublesome when you're simulating sometimes, because we discovered that sometimes the model realizes it's in a simulation environment because there are inconsistencies. So we really need to simulate realistically for the model, not to say, hey, what is going on here? Check your data connectivity, or your historian must be not working, or something like this. Okay, so moving forward. Okay, then we are simulating that we are increasing the pressure, of course. So the model, when it wakes up, sees that there is an increased pressure. But we will not reach the required pressure in this case during this demonstration. So the model is waking up, it's checking the pressure, and I say, well, yeah, I see the pressure is increasing. However, we still didn't reach the required 5.2 bars. So what it will do in this case is using, again, in a completely agentic way, and I would say almost emergent, is deciding to check what is the current rate of change of the signal, and with that set, again, a new wake-up alarm, but in this case, based on the rate of change of the signal. So since the model was showing a lot of muscle, we decided to test it in this case, and we just didn't change anymore the pressure, so we let it run flat. This was the first run we did with this scenario. We didn't really run it many times to see that this will happen. And what we see is that the model wakes up. Let's skip this one. The model wakes up again, and it realizes that the pressure didn't increase. And, well, we didn't expect this, but it realized that down the line there is a secondary pump, the auxiliary pump. So it does recommend, in this case, the operator to say, hey, with the first pump, we are not succeeding to achieve the required pressure, so I think we should start the secondary pump again. Operator confirms, and there it goes. We confirm and so on, and of course, then we increase the pressure to satisfy the ego of the models, and the pressure was achieved. Again, think about this. This is just a demonstration of one single process. This has been tested in production. In fact, we are working already in the second version. This was done in December. Already in June, we are about to put into service the phase 2 with much more increased capabilities, and especially based on a lot of operational experience we gather with real operators running a real power plant. So there is a lot more coming in this sense. Hierarchical organization of agents where they can communicate upwards and downwards with different responsibilities and so on, and much more. I would also want to add, since I have 2 extra minutes, I was a bit faster than I expected. I would also want to add that we are currently done this in 2 places. So we've done this in this power plant control center, where we are controlling 11 power plants. And we are currently starting to do it also with CERN, with one of the large Hadron Collider experiments, the CMS. And we are looking, this is a call for action here, we are looking for 2 extra for this year, where we want to continue piloting the industrial operator to make sure that this productize. We want to make sure first we can push this to end users, and it can be configured for the users, and also that we can go through integrators to their own end customers. So we are not only us who can set up the industrial operator in real environments. We want to collect operational experience in 4 different environments, and we want to do that by Q4, so there is some pressure. So if there is someone really looking for piloting generative AI in real scenarios and control systems, please reach out. We are doing this, basically. 1 minute before. Thank you.
Well, thank you very much for this presentation. You kept your part of the bargain. So as you saw, Bobby is really passionate about AI. He will be in the micro fair, so don't hesitate. Go there. Follow them on LinkedIn, Cleverdist, and you will get all the latest update on Industrial I/O. Thank you, Bobby.
Thank you.